So what do I do with this? So my first instinct on this would be to do a U substitution. And typically in the bottom here, I see a function within a function, and I would usually grab that whole inner function. But I do see that x squared up top too, so I'm wondering if maybe I should use that. So a couple options. One, u could be just x squared, or maybe u should be 1 minus x squared.
Probably go with the second one.
So with the second one, then you just get the square root of u in the bottom, which is kind of nice.
Yeah.
Okay. So let's do that. So that means my du would be just negative 2x dx, right? And this is looking promising, except one thing. I kind of have an extra x in the top. Because here, I'm just hoping for a single x dx. So then I'm going to say, well, what would I do with that extra x? I mean, I suppose I could solve this for x and get a function of u that way, right? And that might lead somewhere. So I'm going to stop and say, I'm not sure this is going to go anywhere. And I'm going to take another twist on this. When I see something like this, I see a piece of the Pythagorean theorem. I can turn that into a triangle by putting 1 here and x there. Then according to the Pythagorean theorem, I would have 1 squared equals x squared plus my adjacent side, let's call that a squared. And 1 squared is 1, subtract over the x squared, then a would be plus or minus the square root of 1 minus x squared. Right, so this side down here, if the hypotenuse is 1 and the opposite side is x, happens to be the square root of 1 minus x squared. So what? Well, anytime I have a right triangle, I can play with trig functions. So because of this triangle right here, I could say that the sine of theta, that angle there, is equal to x over 1, or just x. And the cosine of theta, well, that would be the adjacent side divided by 1, which happens to be just the adjacent side in this case, because I'm dividing by 1. And I can even pull a dx out of this, because here I'm saying that x is equal to the sine of theta. And so if I implicitly differentiate that, then I'm going to get dx is equal to the cosine of theta d theta. So it turns out I can substitute all of the x stuff out of here with trig. So rewriting this, I'm going to get the integral. The denominator is just the cosine, because the denominator is just the 1 minus x squared. So I get a cosine there. dx is the cosine of theta d theta. Well, that's nice, isn't it? Those cosines are going to go away. In my numerator, x squared, well, I can just square my x, which squares the sine. If x equals sine, then x squared has to be sine squared. So I get sine squared in the top. And so that integral above can be rewritten, where we get a bit of cancellation, as just the integral of the sine squared of theta, d theta, which we've done before. I can use the half or double angle formula to get that out. So let's go a step further. We know how to do that using, the formula. Sine squared is equal to 1 minus cosine of 2 theta over 2. antiderivative. Let's see, the 1/2 can just come out. And then antiderivative of 1 is theta. Antiderivative for cosine is a sine, so minus sine of 2 theta. And we have to compensate there with a 1/2, right? And whenever we do a substitution, we usually reverse substitute to get out of it. All right, so let's see what's the reverse substitution going to look like. Well, let's see. I know what sine of theta is equal to. How would I find the sine of 2 theta? Don't we have an identity for that? Yeah, there's an identity for that. I'll write that down. If the sine of theta equals x, what would theta have to be? How would you solve this for theta? It would just be the arc sine. Yeah. Yeah, so if sine of theta equals x, then theta must equal the arc sine of x. So we'll need that. The other thing we'll need here is that the sine of 2 theta is equal to twice the sine of theta times the cosine of theta. All right, so let's do that. So reverse substituting here, actually before I reverse substitute, intermediate step, this part here is twice sine of theta, cosine of theta. And that twice is good because that's going to cancel that half there. I still have the half on the outside. Theta is really what? Arc sine minus the sine is really x. And the cosine is that square root. Got it. You could try the U substitution I started before. It's going to involve that U substitution plus integration by parts, which is slightly more work than this. By a gram of ink.
Is it the arc sine of x?
Oh, that should be an x at that point. Yes, sorry about that. Arc sine of x, correct. Yeah, the sine of theta equals x, then theta, sorry. Yeah, the sine of theta equals x, then theta equals the arc sine of x.
Usually take the arc sine.
Correct, yeah, because the arc sine is an angle. Yeah, that would be weird. Cool, we did it. This is called trigonometric substitution. So we'll do some more examples of this next.